Today we're going to talk about ratios. Mr. Joe loves Simpsons Tapped Out, my favorite game. He is on level 45 actually now. Out of 20 characters, there are 14 males, the rest are females. Find a ratio of females to males. Simplify the fraction if possible. So let's see, females. How many females are there? If there are 20 characters, so 6 of them must be females to 14. So 6 females to 14 males. What's another way of saying that? Isn't it the same thing as saying 3 females to 7 males? Find a ratio of males to females. Simplify the ratio or fraction if possible. So how many males are there? There are 14 males to 6 females. Is there another way I can say that? It's 7 males to 3 females. Find a ratio of females to the total number of characters. Simplify the fraction if possible. So how many females are there? There are 6 females. How many characters? 20. Is there another way I can say that? 3/10. And last but not least, find a ratio of total number of characters to males. Simplify the fraction if possible. There are 20 total characters to 14 male, which simplify to 10/7. 10/7. So ratio. So today we're going to talk about ratio. Ratio is really a multiplicative comparison of two quantities describing the same attribute. You say, what? All right, you have two numbers. You're going to compare two numbers pretty much. For example, I see girls. I see boys. What can you tell me about this compare? Can you compare the females to males or girls to boys? From this picture, from what I can see, there are 2 girls. There are 3 boys. So if I have to describe this as a ratio, I would say 2 to 3. Notice how it is written without units. So ratio is really written just like with 2 numbers because you're just comparing 2 numbers. When we talk about rates and other stuff like unit rates or rates, you will have to write its units behind it. You will have to describe the quantity. So there are 3 different ways to write ratios. One way you could write, if you had to compare 2 numbers, you could write like this, 3 to 5. Or 3, these dot mean colon, 3:5, and then 3/5, or 3/5. I'll be honest, you will mostly see this and this. Sometimes you will see this too. But if I had to see, what do you mostly see? It's usually this one right here. This is what they usually. But then they always say, is there another way you can rewrite this ratio? Because you have to rename it by simplifying it. So usually it's this one. So when I say you have 4:5, it really means 4/5 or 4/5. So it all means the same thing. So let's go to. Does order matter in ratio? Yes, it does. You know, it's just like coordinate plane. When you're graphing an ordered pair, order does matter. So, for example, if there are 3 triangles and 4 squares, when I say find a ratio of triangles and square, I would like you to compare the triangles to square. You would say 3:4, 3/4, or 3/4. If you had written 4:3 or 4/3 or 4/3, you have gotten it wrong because order does matter. As I specifically said, I wanted you to find a ratio of triangles to square. I want you to compare the triangles to the square. So order does matter. For example, if someone said dogs to cat. In this room, there's 4 to 5. Or no, let's make it improper. Let's make it like this way. 7 dogs to 3 cats. So I said, let's look at this room. Let's find the ratio of dogs to cats. And I said 7 to 3. 7 corresponds to the dogs, 3 corresponds to the cats. If you guys said the other way, 3 dogs, 7 cats, you would have gotten it wrong. This order does matter. So you start with the first order, second order. All right, so let's show you why it matters. Brianna is mixing paint and had to add 2:3. Another way to say it is 2:3 or 2/3 of yellow to blue to get a particular shade of green. Because to make green, you have to use yellow and blue. Instead, Brianna wrote 3:2. Does it matter which way she wrote the ratio? Explain why. Yes, it matters because then, first of all, Brianna's mixing paint had to add 2:3 or 2:3 or 2/3 of yellow. So she has 2 yellow, 3 blue. The other way would have been 3 blue and 2 yellow. You wouldn't be able to make green. It'll be like a very, very blue, it'll be more bluish turquoise green. So it does matter. So it's very, very important you follow in particular. For example, it says yellow to blue. Yellow is 2, blue is 3. Order matters. So let's skip this one because there are no students in this classroom. Let's skip this one. Let's skip this one. I actually said, use these jelly beans to work out the following questions. So then I want you to compare the different colors in this jar because ratio is comparison of 2 quantities. So write the ratio. So green to red. So how many greens do I see? I see 1, 2, 3. I see 3 green. 2. How many reds? 4 reds. Is there another way to write this? 3/4 or 3:4. Let's see if I did it correct. Oh, move. I did it correct. Red to yellow. So let's compare. There are 4 red. There are 5 yellow. So 4:5, 4/5, 4:5. Did I do it correct? Let's see. And I did. And last but not least, yellow to red. In this jar, there are 5 yellow, there are 4 red. 5, oh, order does matter. 5-4, 5-2-4, and let's see if I did it correct, and I did do it correct. So it's what we did right here, we found a ratio of the 2 different colors by comparing it. All right, let's do green to all the jelly beans. I see 3 green jelly beans to how many in total? 2, 4, 6, 8, 10, 12, 14. 3 to 14, 3:14, 3/14, and let's see if I did correct, and I did. And then all jelly beans are red, and I know there's 14 jelly beans in all. I cannot remember how many red, so let's go back. I think I see 4. Ooh, I already see I'm going to have a problem right here. 14:4. This is a good answer. I wonder if they're going to make us simplify this. 14:4 to 7:2. 7:2, 7:2. Let's see. They did. So 14:4 is the same as 7:2. And so on. So in this one, so let's do this one. There's another one. Find a ratio of blue M&Ms to the rest of the candy. I see 4 blue M&Ms to the total. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So there's 4 blue M&Ms to 24 candy all. Can that be simplified? Yes, to 2 to 12 to 1, 6. But let's do this one. Let's make it a little more tougher. Let's make it more upper level. What can you tell me about the blue M&M or the total M&M? There is 1 blue M&M for every 6 candy. So that's another way to say for ratio. So here it says there's 4 blue M&Ms to 24 candy. You can see it in the picture. But it's also there's 1 blue M&M for every 6 pieces of candy. So let's see, here's 1 blue M&M for every 6 candy. 1 blue M&M for every 6 candy. 1 blue M&M for every 3, 4, 5, 6 candy. And 6 candy. So it's not. Or another way you could say it, there's 6 candy for every blue M&M. Another way you could say it is there's 6 times more candy for every blue M&M. Or you could say there's 1/6 blue M&M or 1600 blue M&M for every candy. So, find the ratio of boys to girls. So from this list, I see 6 boys. And I see 3 girls. So what's the ratio of boys to girls? 6 to 3. So I am comparing these two quantities. Express this ratio as a fraction. 6/3, simplify it, divide by 3, 2, 1. Now this is where it gets a little harder. Use a multiplicative compare to explain its meaning. So this is boys, this is girls. So say that there are, for every 2 boys, there's a girl. For every 2 boys, there's a girl. For every 2 boys, there's a girl. Can you see it from here? So I will say there are 2, well first of all, let's go back to the solution. Yep, it is. I will say there are 2 times more boys than girls. There are 2 times more boys than girls. Another way you could say is there is half as many girls as boys. Is that true? Yes, there's half as many girls as boys. So that's another way you could describe it. So what you're doing again in ratio is comparing the quantities. So there are 2 boys for every girl, or there are half as many girls as boys. As you can tell from this picture, it is true. There are half as many girls as boys. So let's try another one. Find the ratio of girls to total number of people. There are 3. All right, I don't know why this solution is already shown. There are 3 girls to 9 people, which simplify to 1/3. So what can you tell me about this? For every girl, for every 1 girl, there are 3 people for her. Let's see, 1 girl, 3 people. 1 girl, 3 people. 1 girl, there are 3 people. So I could say there are 3 times more people than girl. Or another way you could say is there's 1/3 or 3,300 girl for every people, or to the total. So at the end of the season, a soccer team has 2 wins, 5 losses, 3 ties. What is the ratio of wins to losses? There are 2, so let's see, wins to losses, 2 wins to 5 losses. Write the ratio of ties to games to play, 3 games to 10 games. And write the ratio of losses to games played. There's 5 losses to 10. Wait, stop. This is good. Oh, as you notice, we are writing the ratio in 3 different forms. But let's look at this one. Could something else be done to this? I think this quantity, these 2 quantities can be simplified to 1/2. So for example, there's 1 for every loss for 2 games. They lose 1 game for every 2 games played. That's pretty bad. Or 2 times the games they play, there's a loss. Or they're half as many, they lose half of every game they play. Alright, so which of the following is not true? This is probably our last screen. So from this one, I see 4 horses and 6 cowboys. Hey, this is from Toy Story. Woody, I think. There are 4 horses to 6 cowboys. There are. 6 of the 10 objects are cowboys. There are. 4 of the 6 objects are cowboys. 4 of the 6 objects are cowboys. What? I don't know. I don't know about C. I don't know. I'm going to come back. There are 6 cowboys. So C is the answer. That's the one that's not true. So what is ratio? Ratio, again, is comparing 2 quantities. You don't write it with any units. That's when we go into rates, unit rates, which is the next lesson coming up. So a ratio is just comparing 2 quantities. You can write it with colon. You can write it with the word 2. And you can write it as a fraction. You will have to simplify if possible. So And there's different ways. So, for example, I say there are 4 horses to 6 cowboys. Another way I say it, for every 2 cowboys, so for every 2 horses, there are 3 cowboys. And that's it. So that's ratio.